Thank you, sir, for giving me this opportunity. I am here on the behalf of Professor P. Mandal. At present, he is not in Roorkee here. He has some other work in Jaipur. So I am just here presenting our work, what we are doing at IIT Roorkee. As sir has explained my work on the life cycle assessment of arsenic and fluoride removal technologies, I had also done the life cycle assessment work on the recycling of plastic waste. We have just done with two recycling methods. One is tertiary recycling and one is secondary recycling, and compared the impact. So I'm just presenting the work, which is, the whole work is not here, but just showing the products we are developing out of recycling of waste plastic. Next slide. So this is my content of presentation. Next. Circular economy, as other speakers and sir has already explained what is circular economy. The aim of the circular economy is to keep the product in use and maximum use of resources, and the recycle is also one part of that circular economy. Next please. And that the circular economy doesn't mean undermining the needs of biosphere. So these are the 7 pillars of the circular economy. Next. So the circular economy, the benefits of circular economy, that it reduces the total greenhouse gas emissions, the demands of raw materials, and it creates more jobs and etc. And please next slide please. So waste plastic is a major challenge, as Ma'am Isha has already explained how much big problem it is. And as Ma'am has explained that US report data that 133 billion worth we are wasting just by not recycling the waste packaging plastics. So waste packaging plastic is a major challenge because of its widespread littering and choking the sewer line, and it is creating a lot of pollution. The recycling of that waste packaging plastic is very much needed, but the collection and other steps are also very important, which need to be taken out. Next slide please. So the roots of waste plastic management are just first and most favorable route is just reduce the consumption of waste reduce the use of plastic. But at present, in present condition, the banning of complete ban of the plastic is not favorable, and because of its very user friendly nature. And reuse, multiple times we can reuse the plastic product. Then the third one is the recycle, and then recovery of some chemicals and energy from that waste plastic, and the landfill. But after reuse, multiple reuse, if the product get breakage, so we have to do something, and we are here is the route for recycle. The next. Now, types of recycling, there are primary recycling, secondary recycling, tertiary recycling, and quaternary recycling. So in the primary recycling, we just make a product of similar quality of that original product. In the secondary recycling, we make a product which has somewhat less characteristic than the original material. In the tertiary recycling, we just extract energy or fuel, energy or chemical feedstock from that waste plastic. In quaternary recycling, we just incinerate it. And some CPCB recommended options are making that polymer coated bitumen, plasma gasification, liquid fuel production from that waste plastic. But we have conducted a life cycle assessment work at IIT Roorkee and compared the recycling techniques of secondary recycling and tertiary recycling, and it has already been reported in other studies also that the secondary recycling is more environmental friendly than the tertiary recycling. So first, when we do the secondary recycling for several times, and then when we go to the tertiary recycling of that recycled plastic, then it would be more beneficial for the environmental point of view. Okay, and then next. So what we are doing at IIT Roorkee, just we are making useful products such as paper blocks, wall tiles, and army trackways from the waste polyethylene packets, packaging plastic. And in the previous work also, that waste packaging plastic has been used for paper block making. But in the previous work, shredded plastic has been just mixed with the cementitious material, or plastic melted and then mixed with cementitious material, and plastic and sand melted simultaneously, and that for making paper blocks and other products. But the issue with these three things are there. That when we are using cement, so cement is one of the largest contributor of the greenhouse gases. As per the recommendation of IPCC, one should move toward some radical innovations which can avoid the use of cement. So when in our technology, we are using the third. It is similar to the third one, where we are completely replacing the use of cement and using waste plastic as a binding agent. And with some waste materials which are from other industries. So like sir has explained my work on the arsenic and fluoride removal technology. So we are using the spent sludge from that the water treatment plant, which contain the aluminum hydroxide in the that making the plastic paper blocks. It is acting as a fire retardant in that plastic paper blocks. So we are using the waste materials totally in that study, and we have also done published a life cycle assessment work on comparing the different technologies for recycling of waste plastic in this making that useful product. So that work has already been published in reputed international journal. Please next. So these are our product. The first one is the paper block. It is completely replacing the use of cement. And second one is the floor tile, and third one is the army trackway. By seeing the quality of our product, paper block and wall tile, Indian Army has contacted us for making the army trackway. At present, Indian Army is using aluminium based trackway for desert and muddy areas. But their weight is very high. For 25 meters, the weight is around 350 kg. So for that, they are requiring spending large amount of money for transportation, and they are getting difficulty in loading and unloading. So they just contacted if we can do something with this material, with this composite, and if it is possible to reduce the weight. So just by we are using the same composite for which we have used for paper block, and the trackway has reduced. The plastic trackway has less than 50% weight of that original aluminum based trackways. And we are also developing a new product, a speed breaker from waste plastic. Next. So these are the value proposition of our product. The product is relatively low cost, and that the army trackway I have presented, it has reduced the cost around 1/3 of metal based trackway, which current Indian Army is currently using. And the product are fire and heat resistant, unbreakable, and it has fair resale value, and after multiple we can recycle it multiple times. Anti-skid properties, high durability, and eco-friendly nature that I have already explained, that we have conducted all the life cycle studies and published in reputed journal. And low production time, as cementitious product requires 28 days for ultimate strength, curing time, but this product doesn't require this time. Next. So this is the field trial we have conducted at IIT Roorkee, and in 2 years there is no change has been observed till now. We have fixed it in 2021. Next. This is the field trial of Army Trackway conducted by 59 Engineering Regiment of Indian Army. So over the multiple movements of tanks and army trucks, it has shown very good performance. And so now we are just upgrading the design, and our army is giving us a new project for this thing. Next. So the previous prior arts has the issue of high greenhouse gas emissions and high cost materials. So this innovation is giving the solution, sustainable solution for waste plastic recycling, and the production cost of these products is also very less. The production cost of that wall tile we are producing is around 15 rupees per square feet. There is no tile available in the market which has such low cost. And paperworks also has competitive cost to the commercial available product, and the cost of trackway is around 1/3 of the currently used metal based trackway. Next. So the present technology is providing sustainable solution for waste plastic recycling, and avoiding the use of cement and metal based trackway, metal based materials, and producing low cost paver block wall tiles and trackways. And we are developing new design for these products, and the process can be applicable for both small scale and large scale application. So thank you all very much for giving us this opportunity to present our work. Thank you.